Hello friends, what's up? Welcome back to Maths by Gurpreet Sekho, and I'm Gurpreet Sekho back with another exciting video of chapter triangles. So far we have completed our 7.1 in which we have discussed congruency criterions, different congruency criterions, that were 3, and today our first topic of 7.2 exercise is our theorem. That is very important. It's under the heading Theorem 7.2. Okay, so let me write the statement, and without wasting even a second, let's start with the proof of this theorem. This is our statement of Theorem 7.2. It states that angles opposite to equal sides of an isosceles triangle are equal. Firstly, decipher the statement. Angles opposite to equal sides. Now this is an isosceles triangles, and these dashes means these sides are equal. So now these two sides are equal to each other, and angles opposite to these two sides, of course those are B and C, because the angle opposite to AC, that is B, angle opposite to AB, that is C. So we have to prove that these angles, angle B and C, these are equal to each other. So what is to be proved? That is angle B is equals to angle C. Now you don't have to do anything else, just remember your congruency criterions, that SAS and other criterions, and you will simply just divide the one triangle into two triangles by drawing a bisector, and then we can easily prove. So let's start with the proof. Now firstly, you have to do a little bit of construction, because you know that if we want to apply the congruency criterions, we need two triangles, not one triangle. So just make one triangle into two, draw a bisector AD. Okay, now bisector AD means it is dividing the side BC into two equal parts. Okay, it is intersecting. So this angle is also 90 degree, this is also 90 degree. So yeah, now we have two triangles. What are the two triangles? That is triangle ABD and triangle ADC. Angle B and angle C are two angles of these two triangles. So what we have to do here, we have to prove that these two triangles are congruent to each other. Then by applying CPCT that we have discussed, we can literally make these both angles equal to each other. Okay, so let's start. Now we have to prove that these two triangles are congruent to each other. Firstly, now see what sides or which angles you can make equal to each other. Firstly, you can clearly see that AB is equals to AC. Why? Because it's given. AB is equals to AC. It's given. What's given? Because it's a isosceles triangle, so two sides are already equal to each other. Now AB is equals to AC given, one side is done. Now rest, what you can see, that ADB is equals to ADC. Of course it's 90 degree, right, because it's bisector. You can write this as well, because this can be proved in many ways. On your book they have written AB is equals to AC, then they have proved that BAD is equals to CAD. Now let's write that. Why this? BAD is equals to CAD, because we have constructed it. And how we can write this? Because this is a perpendicular bisector of angle A. Now perpendicular bisector means the BAD angle will be equal to DAC. So that's why we have constructed a bisector, and that's why these both angles are equal. Now one side is equal, one angle is equal. Now let's see one more side, if it's equal or not. You can clearly see AD. AD is equals to AD. Why? Because it's common in both of the triangles, right? Now SAS, it means triangle ABD is congruent to triangle ADC. Why? Because of SAS criterion. Clear? Now these two triangles are congruent to each other, so you can literally write therefore angle B is equals to angle C. Why? Because of CPCT. It means congruent parts of corresponding paths of congruent triangles, because these two triangles are coming out to be congruent to each other. So all of the angles and all of the corresponding sides and corresponding angles will be equal to each other. So that's why we have written angle B is equals to angle C. So yeah, in this way this theorem can be proved very easily. So now let me write the statement of converse of this theorem, but we are not going to prove that because you can easily do that. You have to just go from bottom to top and then you can easily prove the converse, but I will surely make you understand the converse of this theorem. If you find any problem in attempting or solving the converse of this theorem, you can DM me on my Instagram ID, which is given in the description, and you can also use the comment section. So firstly, let me write the statement of its converse. This is the converse of the theorem that we have just proved. Now the sides opposite to equal angles are equal. We have to prove that the sides like AB and AC, which are opposite to equal angles, so B must be equal to C, and the side is AC and AB, so AC must be equal to AD because B and C are equal. This is the statement, right? Now I will only explain it theoretically because I want you guys to practice it on your notebooks. Okay, so now again we'll prove that triangles are congruent. What will you do? You will again do the construction of a bisector and again divide the angle A into two equal halves. Okay, so now angle B is equals to angle C. That's given. One angle is done. And then these two angles, right? BAD and DAC, again one angle is also equal to each other. So one angle is done, another angle is also done. What's left? One side, that is AD is equals to AD, again common. So yes, by applying A congruency rule, these two triangles are congruent. That's why the remaining corresponding side, that is AB and AC, these both are also equal. Yeah, so this is how you can prove this. Now I guess I have theoretically explained each and every step of the converse of this theorem, but still if you find any problem, you know how to contact me, and I'll be more than happy to assist you there. Okay, so let's start with the example, so that just to apply this theorem and just to make things more clear. This is our first example of exercise 7.2. The statement is, in triangle ABC, bisector AD of angle A. So let's first just see the diagram as well. In triangle ABC, bisector AD of angle A. Now AD is bisecting angle A. Done. Is perpendicular to side BC. It is perpendicular to BC. It means this angle is 90 degree. This is also 90 degree. And we have to show that AB is equals to AC and triangle ABC is isosceles. Now you can clearly see that if AB is equals to AC, then automatically the triangle will become an isosceles triangle. So yeah, we have just proved the theorem and we have to follow the same steps that we have just used. So yeah, let's start with the sum. Firstly, it's clear that we have two triangles. In triangle ABD and triangle ADC or ACD, right? Now we have to prove that these two triangles are congruent to each other, right? So what will we first see? That what sides or what angles are equal to each other. Firstly, let's start from the very basic, that these two angles are 90 degree each. We can clearly write that angle ADB is equals to angle ADC because 90 degree each. One angle is done. Okay. Now one angle is done. The rest part AD. AD is again is equals to AD because it's common. It's common side. Now after that, this angle is also getting bisected into two equal parts. It means first A is done, then one side is done. Then again have a look at another angle, that angle BAD is equals to angle DAC. Why so? Because it's being bisected. Okay, so these two angles are equal to each other. Now from ASA rule, triangle ADB is congruent to triangle ADC, okay, or triangle ABD is congruent to triangle ACD by ASA rule. Yeah, so you have seen that how simply we have applied ASA rule, right? Now after that we have to prove that AB is equals to AC. Again, these two triangles are congruent, these sides are equal, so corresponding parts are also equal. Therefore AB is equals to AC using CPCT. Now AB is equals to AC, which means ABC is an isosceles triangle because two sides are coming out to be equal to each other. So yeah, in this way you can prove any statement, and I think that it's very easy. We just have to see that which sides are equal to each other and two triangles will be automatically congruent to each other. Just you have to keep in mind these kind of congruency criteria. Okay, let's move to the next one. Let's read the next statement. E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. Triangle ABC is given. AB and AC are two equal sides. E and F are midpoints of the equal sides. It means AEEB are equal to each other, AF, FC are equal to each other, okay? Because these are halves. We have to show that BF is equals to CE. Now you can see that in this we have to pick two triangles which are required, BF and CE. BF is the side that is included in the triangle ABF. CE is the side that is included in the triangle ACE. Okay, so we have to take these two triangles only. So what will you write in triangle ABF and triangle ACE only? We will prove that these two triangles are congruent to each other. Only then by applying CPCT we can prove that BF is equals to CE, right? So firstly, in ABF and ACE, you can clearly see that angle A is common. So yeah, firstly write, which is very clear. Angle A is equals to angle A. It's very common. Now the other thing that is already given in the statement, AB and AC are equal to each other. So you will write AB is equals to AC. That is already given. Now one angle is done, one side is done. Now let's see if the third one is also side or it's an angle. Okay, so now you can see that AF is equals to AE. Why? Because AF is also half of AC, AE is also half of AB, and these are the halves of equal sides. You know that AB is equals to AC, it's given. So it's pretty much clear that AE must be equal to AF because these two are the halves of the equal sides. Okay, so that's why AF will be equal to AE. Why? Because these are halves of equal sides. These are equal to each other. This is again a side, so we can easily write triangle ABF is congruent to triangle ACE by SAS rule because two sides and one angle is included. Now these two triangles are coming out to be congruent to each other, so automatically BF is equals to CE by your favorite thing, yes, that is CPCT, corresponding part of congruent triangles. So this is how you can prove. Just a simple thing, just you have to use your presence of mind that which sides are equal to each other and which angle is equal to each other, what can taken out as a common thing, and what's already given, and what can be equated using the concept of the statement. Yeah, you just have to use presence of mind. So yes, this was the example 5th, and you have seen that it's very easy to prove examples like these. Now only one example is left, so yeah, just complete that. This is the last example that we have to do to complete this exercise. In an isosceles triangle ABC with AB is equals to AC. Okay, this is an isosceles triangle. It's given. D and E are points on BC. D and E are points on BC such that BE is equals to CD. BE is equals to CD. We have to show that AD is equals to AE. Okay, so now AD is equals to AE. It means we have to prove that these two lengths are equal to each other. It means we have to take two triangles which are including these sides. So those two triangles will be ADB and AEC. Okay, so in triangle ABD and triangle ACE, you have to prove that these two triangles are congruent to each other, right? Only then you will make AD is equals to only then you will make BAD is equals to AE. Yes, yeah, that's to be proved. Okay, now you can see clearly that one side is already given, that AB is equals to AC, because it's an isosceles triangle with two equal sides AB and EC. So simply AB is equals to AC. Why? It's given. It's literally given. AB is equals to AC. One side is already done. After that, angle B is equals to angle C. Now you have to really jog your memory a bit, because the theorem that we just have completed, the angles opposite to equal sides are equal. So these are the angles which are opposite to equal sides AB and EC by theorem 7.1. Okay, so angle B is also angle equal to angle C. Now one side is done, one angle is done, one more side is to be equated. So we'll use the given condition, BE is equals to CD. But you can see that BE is not the side of ADB, and similarly CD is not the side of AEC. So what we have to do, we have to form BD and EC somehow. You will subtract DE from both sides, BE minus DE and CD minus DE. We have done nothing, because in order to obtain BD and CE we have to do this. Now BE minus DE, BE minus DE automatically equal to BD, and CD minus DE automatically is equals to CE. Okay, so yeah, then third side is also equal. So triangle ABD is congruent to triangle ACE by SAS rule. Now what we have to prove, we have to prove AD is equals to AE. Therefore AD is equals to AE. Yeah, it's D. Okay. AD is equals to AE by CPCT, corresponding parts of congruent triangles. So this is how you can apply theorem 7.1, similarity criterions, and sometimes you have to introduce some of the things from yourself in order to obtain the equations that are desired. So yeah, you must be ready to do that as well. Otherwise these sums are really easy and they can be solved like in a second. So that's why just be present while doing the sum. Be mentally present, of course, physically you must be. So yeah, presence of mind is must for attempting sums of geometry. All right, so that is all for today's video, because we have completed the exercise 7.2 today. Now you can start doing sums, and feel free to ask me any problems in the comment section, and also all the suggestions are invited. So you can use comment section, or you can DM me on my Instagram ID, which is given in the description. So don't forget to press the subscribe button, because only that's the motivation that you can deliver in order to get these kind of videos regularly. All right, so have a nice day and keep practicing. So yeah, see you in the next video. Thanks for watching. All the very best.